We now discuss the solution of the problem from the section three-dimensional geometry. The given question is on a given plane and given 2 points to decide whether these 2 points lie on the same side of the plane or on the opposite sides of the plane. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, let P be the plane passing through the intersection of the planes. The vector r dot I plus 3j minus k is equal to 5 and vector r dot 2i minus j plus k is equal to 3 and the point 2 comma 1 comma minus 2. Let the position vectors of the points x and y be I minus 2j plus 4k and 5i minus j plus 2k respectively. Then the points x and y, we are given options. Option A, point x and x plus y are on the same side of P. Option B, y and y minus x are on the opposite sides of P. Option C, x and y are on the opposite sides of P. Option D, x plus y and x minus y are on the same side of P. We are given a plane P is passing through the points of intersection of these two planes and the point 2 comma 1 comma minus 2. We are given two vectors, 2 points whose position vectors are I minus 2j plus 4k and 5i minus j plus 2k. Then we have to decide these 2 points. In the option A, 2 points are x and x plus y. In the option B, y and y minus x and so on and so forth. We have to decide whether these 2 points will lie on the same side of P or on the opposite sides of P. That is our given question. We now discuss the solution of the problem in detail. Let's call the 2 planes B P1 and P2, where P1 is r dot I plus 3j minus k is equal to 5. P2 is r dot 2i minus j plus k is equal to 3. Where r is xi plus yj plus zk. Take that. Take the dot product with I plus 3j minus k and bring this 5 to the left hand side. Then the equation of the plane P1 will become x plus 3y minus z minus 5 is equal to 0. Similarly, P2 will be 2x minus y plus z minus 3 is equal to 0. And we are given the plane P is passing through the points of intersection of the planes P1 and P2, and that will be given by P will be given by P1 plus lambda times P2. That is, P1 is x plus 3y minus z minus 5 plus lambda times P2, that is 2x minus y plus z minus 3 is equal to 0. To evaluate this lambda, we are given the condition that this plane P is passing through 2, 1, minus 2. So substitute x is equal to 2, y is equal to 1, z is equal to minus 2 in the above equation. Then you will get this one. Then simplify, you will get 2 minus 2 lambda is equal to 0. That will give rise to lambda is equal to 1. Now put lambda is equal to 1 in the above equation. Then you will get x plus 2x, that is 3x, 3y minus y plus 2y minus z plus z 0 minus 5, minus 3, minus 8. Therefore, the equation of the plane is P of xyz is equal to 0, where P of xyz is 3x plus 2y minus 8. We are given capital X and capital Y, 2 points, whose position vectors are I minus 2j plus 4k and 5i minus j plus 2k respectively. Therefore, capital X is the point 1, minus 2, 4, and capital Y is 5, minus 1, 2. We continue in the next slide. Let's look at our options. In our options, 2 points are given. In the option A, x and x plus y, where x is known, y is known, x plus y. To decide whether it is on the same side or on the opposite side. And in a similar fashion, in B and C, D is given, and the correct option we have to find out. That means, in an essence, how to decide given 2 points and given a plane, whether they lie on the same side of P or on the opposite sides of P. That's the question. So, for that, in that direction, we have a result. Let's recall the following result. Let ax plus by plus cz plus d is equal to 0 be the plane equation, let's say capital P, and we have 2 points A and B whose coordinates are x1, y1, z1 and x2, y2, z2. And the points that A and B are on the opposite sides of P if this ratio ax1 plus by1 plus cz1 plus d, that is the value of the P at the point x1, y1, z1. So, ax1 plus by1 plus cz1 plus d by ax2 plus by2 plus cz2 plus d, evaluate, and if it is a negative, that is P of A, the value of P at A by P of B, if it is a negative, then they lie on the opposite sides of P, and they lie on the same side of P if this ratio is greater than 0, that is positive, that is P of A by P of B is greater than 0, that is positive, then these 2 points A and B lie on the same side of P. So, taking this result, and we discuss in the next slide. Options are here in the bottom. Agreed. Now, we have x, that is 1, minus 2, 4, y, 5, minus 1, 2. P of x, y, z is equal to 0, where P of x, y, z is 3x plus 2y minus 8. To discuss the 4 options, we have provided you a table. So, here A, B, these are points, A is the point, B is the point. P of A, that is the value of P evaluated at the coordinates of A, P of B, and P of A by P of B to decide whether it's positive or negative. Then get the conclusion whether x and y are on the same side or lie on the opposite sides of P. Agreed. Let's take the first case, that is option A. In option A, x and x plus y are given. So, x is here. X is 1 minus 2, 4. X plus y, add these two, we'll get 6 minus 3, 6. Evaluate at A, P at 1, 2, 1 minus 2, 4. That is 3 into 1, 2 into minus 2, minus 8, which is negative. And x plus y is 6, minus 3, 6, and evaluated. So, P 3 into 6 plus 2 into minus 3 minus 8. So, this is 3 6 are 18, minus 6 minus 8, definitely it is positive. So, it is a negative by positive is negative, it lies, that means these 2 points lie on the opposite sides of the plane P, and it is in the option it is given same sides, therefore option A is false. So, also in the case of option B, y and y minus x, y is here, y minus x is here, and P of A, P of y is positive, P of B, that is P of y minus x, is also positive, positive by positive is positive, therefore they lie on the same side of P. So, in option B it is given opposite, and we got same side, therefore option B is false. Let's jump to the option D. Option D. In option D, x plus y, x minus y, x plus y is here, x minus y is here, P evaluated at x plus y and P evaluated at x minus y. So if you see, P of x plus y is greater than 0 positive and P of B is negative. So positive by negative is negative, therefore they lie on the opposite side. In the option D, it is given on the same side, therefore option D is false. So in the option C, x and y, P at x is negative, P at y is positive, negative by positive is negative, that is opposite, so they lie on the opposite sides of P, and it is given in C, opposite sides, it tallies, therefore option C is the correct answer. Okay, we have done in a serial order, and of course after first two rows we have jumped to the option D. Now normally the student psychology is that he will test for x and y, because x and y are ready made there. What happens to x and y, whether they lie on the same side or on the opposite sides? So in this case you get an answer. You get an answer. Stop doing the remaining. Suppose option C is not true, then anyway you have to try from the beginning. But anyway, the student psychology is he will test for x and y and he gets the answer. So therefore he is lucky. So that is the question, and the answer to this question is option C. That is the detailed discussion of the solution of the problem from the three-dimensional geometry. That is, we are given a plane and given 2 points, and to say whether they lie on the same side of P or on the opposite sides of P. It's a good question. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.